Software is a set of programs or a collection of programs. The system software is also going to serve the service of the users. Third process is waiting for the second process. Then first process is waiting for the third process. So this keeps on waiting, and the jobs are processed in the order of submission in the form of first come first serve fashion. Hello everyone, it is Dr. Ravikumar YB, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's session, let me explain about the operating system which is in your syllabus. That is, third unit is a operating system. Let me take you into the details of operating system one by one. Here, first of all, the definition of this operating system stands for: it is a system software. Software is a set of programs or a collection of programs that manages the computer hardware. It also provides a basis for the application programs and acts as an intermediary between the computer, user, and the computer hardware. So, what is that interface that interacts with the computer hardware as well as the users? That is the system software called operating system. So, in this operating system, you are going to learn about the different functionalities of operating systems, that is the process management, memory management, scheduling criteria, and which are the problems the system will encounter if there are many processes to be executed at the same time. All those things are certain set of functionalities which you are going to learn in case of an operating system. If that is the case, you will see that in this pictorial representation, there are users. User 1, user 2, user 3, so on up to user n. User n may be n number of users who wants to use that computer system. So, which is the task the user 1 is doing? User 1 wants to perform the operations of compilation. So, user 2 wants to do the task of assembly operations. User 3 wants to perform the task of text editing. Then the user n wants to perform the operations of database management system. All these are called as application softwares. All these are called as application software. What is the meaning of application software? Any software that is built as an application to serve the purpose of a user, then we say that it is an application software. And of course, the system software is also going to serve the service of the users, but the main distinguishes that we can observe between the system software and the application software is: the system software is an operating system that interacts with computer hardware and users. So it is an interface between a user and the computer hardware. Then what about the application software? An application software is a software that interacts with another system software as well as users. That is the main difference between an application software and a system software. Then, if you look at this application software interacts with operating system as well as the users, right? What about this system software? System software interacts with computer hardware, in turn interacts with users through the application software, so that we say that an operating system is a system software that interacts with computer hardware as well as users. So I will call it as an intermediary software. An intermediary software. So, if it is the case, the operating system, the application programs, and the users, we have the hardware. We have 4 segments here. This is the first segment. In the second segment, you are going to observe the application software. In the third level or in the segment, you are going to find out the system software. As in the third segment. In the final segment, you will see that the hardware devices, that is the fourth level or fourth segment, you are going to see the computer hardware. So with this, we are going to learn the system software and operating system. That is, the operating system is going to be taught in detail. Then we have the computer components. Which are the components we will observe generally? The CPU, also called as central processing unit. Then the memory. If we have a memory, we have to perform the operations on memory. Then the input operations or IO devices, which provides the basic computing resources for the system. All these are called as an hardware devices. All these together are called as an hardware devices. Application programs, let me take you about such as word processors, spreadsheets, compilers and web browsers, which defines the ways in which these resources are used to solve users' computing problems. What are all these? All these are called as application softwares. So we have an operating system then which controls and coordinates the use of the hardware among the various application programs for the various users. That is, this operating system is the one which interacts with the system software. That is, the operating system interacts with users as well as the hardware devices. That is the thing we are going to observe. From the user point of view, what is the goal of an operating system? The goal of an operating system is to maximize the work and minimize the efforts of the user. That is, it has to work in conjunction with the users. It has to minimize the work of users and maximize the work of operating system. That is the task. Most of the systems are designed to be operated by single users. However, in some systems, multiple users can share resources such as memory. In these cases, operating system is designed to handle available resources among multiple users and CPU efficiently. Please remember it carefully, my dear students. We have a single user here. When a single user uses the local system, there is no need of sharing the hardware devices such as memory or time, or it may be in terms of CPU. But when multiple users, so this is the user view, users view. Here user 1. User 1 interacts with hardware devices through an operating system. Through operating system. Suppose if there are multiple users who wants to use the hardware devices, then through operating system, then this indicates that the hardware devices are shared, or the resources are shared among the multiple users. The resources may be in terms of memory or CPU utilization, which is referred to as the cycles per second, CPS, cycles per second, which is referred to as the frequency. If it is a frequency, we have which is inversely proportional to time. So we have the values like time as well. So time is another important resource. Frequency is another important resource. So we need a scheduling criteria to schedule all these tasks and operations to be carried out by the operating system in case of user view. So what is that I can suggest you all is a single user can use the entire resources of a system, or multiple users can share the resources of the system among themselves. This is from the user point of view. If we look at this further, operating system must be designed by taking both usability and efficient resource utilization into view. In embedded systems like this, automated systems, user view is not at all presented. That means these softwares or application programs are embedded into the hardware devices. Where is that hardware? Suppose if I have an Arduino board or if I have a Raspberry Pi, I will incorporate some Python programming language into these hardware devices so that the hardware device must work as if the user is working in the environment. In such cases, do we have any users? No, we do not have any users there. It is an automated system. It is an intelligent system which is working as if the user is working in the environment. All these are called as intelligent systems or autonomous systems needs to address the user point of view. But the user definitely will not understand what is going on from the user point of view. But the system is going to work as if the user is working in the environment. So we do not have a user point of view. So user point of view, if that is the case, operating system gives an effect to the user as if the processor is dealing only with the current task. But in the background, processor is dealing with several processors. For this, let me give you one example. Operating system. Now I am talking about operating system. In the future and next subsequent sessions, I will talk about RTOS. What is the meaning of RTOS? That is real-time operating systems. You people might have seen the robotics which is used in the manufacturing plants of cars, wherein one of the robot brings in the mechanical instruments into one place and another robot will be keep on waiting for the input of one of the robot, and as soon as it receives an robotic mechanical device, it starts working with other devices. So what is that? There is a chain, there is a link from one of the robots to another robot. There may be one more robot which is waiting for an input from this robot. So there is a sequential link from one of the robotic operations to another robotic operations. It has to work according to the schedule, according to the real-time operations. Suppose if any one of the robot fails, then the entire system gets collapsed. So that is the reason a real-time operating system is one that interacts among themselves and works as if the user is working in the environment. Please be careful when you understand or when you visualize any of the videos wherein you will see that one of the robot is bringing the mechanical device into the place. Another robot will be keep on waiting for this input, and one more robot may be waiting for this input, and there may be a chain of these robots which is waiting to work in operation in sequential. So these sequential operations require the execution of all these robots in time according to the schedule. So this is called as an RTOS, also called as real-time operating systems. But I'm talking about the operating system in today's class. So it is a single system. The single system is going to be shared among multiple users. If it is shared among multiple users, then multiple resources, that means all these resources are shared among multiple users. That is my point of explanations in this class now. From the system view, from the point of view of system, I can say that the system point of view, operating system is a program or a collection of programs which is involved with the hardware. Then operating system is an allocator which allocates memory, resources among various processes. It controls the sharing of resources among programs. It prevents the improper usage error and handles deadlock conditions. The same thing I was explaining about this. That is, when one of the process is waiting for the first process, third process is waiting for the second process, then first process is waiting for the third process. So this keeps on waiting. This situation is called as a deadlock situation. These deadlock conditions are prevented if the proper usage of processes management are done by the operating system. Otherwise, it is very difficult. The system will land up in a deadlock condition. So in order to avoid all these things, the operating system must be efficient enough to allocate resources, that is memory, among multiple users, so that the sharing of resources among multiple programs and users is worked according to the requirements of the users or programs. Then the system view and system goals. What is the objective or goal of a system, and how we can see the view of that, how we can see the goal of that system view. It is a program that runs all the time in the system in the form of kernel. What is the meaning of kernel? I am using the word kernel here, K-E-R-N-E-L, kernel here, which is an inbuilt software. It is an operating system. An operating system is a control program. A control program manages the execution of user programs to prevent errors and improper use of the computer. Suppose when you perform the word processing operations, if you want to play the music in background, you can do so. Multiple operations and multiple tasks are done by the users. And of course, it is possible. When it is given as a process to the system, the process needs to manage all these work, that is word processing operations as well as music playing operations as well as many other types of distinct types of operations at the same time. If that is the case, parallel processing operation is to be taken care of. So parallel processing is done when we have multiple cores of system architecture, that is single core, dual core, quad core of architecture that allows you to perform the operations of multiple tasks simultaneously. That is from the view of system viewpoint. Similarly, we have a batch processing system. What is the meaning of batch processing system? Let me clarify you that. Suppose if I have one of the job, second job, third job, fourth job, all these are similar, but this is the job of user 1. This is the job of user 2. This is the job of user 3. This is the job of user 4. If that is the case, of course, many people are doing the similar set of jobs. Then the user 1 is doing one more different type of job, that is user 1, user 3, user 4. So user 1, user 3, user 4 are doing job 1, job 1, job 3, job 4, job 2, job 3, job 4. So you are observing that these jobs are similar. When they are similar, job 1 is done by all of this. That is job 1 of user 1, job 3 of user 3, job 4 of user 4. All these are similar. Job 1, job 3, job 4 are similar, but of different users. And of course, it is of similar. I'll call this as batch 1. Similarly, I have these jobs, job 1, job 2, job 3, job 4 of user 1, user 2, user 3, user 4 respectively. Then I will say this as batch 2. So what is that I am doing here? If there are similar set of jobs, I will cluster them. I will combine them into one single batch. So the processing of this entire batch is done. That is called as a batch processing system. See here, batch processing is a technique in which an operating system collects the programs and data together. That is, collects the programs and data together in a batch before processing starts. An operating system does the following activities related to batch processing, which is the task. The first one is OS defines a job which has predefined sequence of commands, programs, and data as single unit. Pre-processing directives, as you have already seen, that is macro expansion. Similar to that, if there is any such kind of predefined sequence of operations and commands and programs which needs to be carried out as a single unit like this, then it is called as a batch processing operation. Then we have the OS keeps a number of jobs in memory and executes them without any manual information. That means it does not require any manual intervention because all of these jobs are similar. So all these similar jobs are executed by the batch processing system without any manual information. So if you look at this, you will clearly understand that job 1, job 2, so on up to job n. N may be 10, 20, 30, 40, any number of things. But which is that operating system which is doing the top of job of this? That is the batch. So we have one of the batch. In this batch, we have 1 to n number of jobs. We have another batch in which we have 1 to n number of jobs. And we have one more batch in which we will be having 1 to n number of jobs. All these jobs are processed by whom? It is going to be processed by Central Processing Unit. Or CPU. In short, I will call this as a CPU. When a job completes its execution, its memory is released and the output for the job gets copied into the output pool. It is pool for the later printing processes. This is called as the batch processing system. This is the objective of this batch processing system. And the jobs are processed in the order of submission in the form of first come, first serve fashion. That is the order in which they arrived into the batch processing system. In the same order, it is going to be produced. The output is produced. Similarly, the advantages of batch processing system includes operator is reduced. Then it increases the performance as a new job gets started as soon as the previous job is finished without any manual intervention. As soon as the first job is finished, it picks up the second job. As soon as the second job is finished, picks up the third job, so on and so forth. Then what is the disadvantage of this? It is very difficult to debug the program. Then a job could enter an infinite loop because if there are multiple jobs or multiple tasks to be carried out, that leads to an infinite loop. That is another drawback. Due to lack of protection scheme, one batch job can affect the pending jobs. Suppose if the second job takes on for a long time of execution, the third job needs to wait in queue. That is the thing we need to understand here in case of this. That is another drawback. So these are the drawbacks and advantages of batch processing system. So dear students, kindly come back to me during the live sessions if you have any questions with respect to the topic I discussed in today's session. Thank you very much. Thank you one and all.